Problems involving complex summation technique IB. Okay, so in this video we will solve this problem, and we have been doing a lot of such problems in this channel lately, and this is the fourth one in this series. I think this will be the last one, because if there are other variations, it might also involve other techniques. So I think this is the last one that we will do, and I think you are already adapted with how we will go on. Yeah, just express sine as the imaginary part with the pi theta, and then you can take this real number inside the imaginary part, and then use the linearity of imaginary part and just take it outside. Yeah, and just sum the exponentials, get the answer, and then find the imaginary part. So that's how we will solve this problem. Now let's begin. So sum from n equals to 0 to infinity 1 by 2 to the power n, and now this is just imaginary part of e to the power I and pi by 2. Yes, now take this inside, take this inside. Okay, and also use the linearity so that we have imaginary part of the sum from n equals to 0 to infinity e to the power I and pi by 2 by 2 to the power n. Yes, now again this is just the imaginary part of sum from n equals to 0 to infinity e to the power I pi by 2 by 2 to the power n. Yes, now if you have to sum this, since the modulus is just 1 by 2, which is less than 1, we can use the infinite GB formula, and that will be a by 1 minus r. Yes, okay, and now this will be imaginary part of 2 by 2 minus e to the power I pi by 2. Yeah, now just to find imaginary part, if it was just real numbers in the denominator and some real imaginary numbers in numerator, that would be easier to find. Yeah, but over here this will just give both real numbers and imaginary numbers in denominator as well. Yeah, yes, so that's why it's basically necessary to make just real number in denominator, so that it has to first find the imaginary part of the entire expression. Yeah, now for that, either you can just first of all express this as cos and sine and then rationalize it, or the other technique is to multiply by same number but with a conjugate over here. Let us see how. Multiply by the same number but with the conjugate. So basically multiply by 2 minus e to the power minus I pi by 2. Yes, 2 minus e to the power minus I pi by 2. Now this gives us, this will be the imaginary part of 4 minus 2 e to the power minus I pi by 2, and now this is 4 minus 2 times e to the power I pi by 2 plus 2 minus I by 2 is basically 2 cos pi by 2, and then plus 1. Yes, now the denominator is totally a real number now. Yes, you can see that. Now just find imaginary part from numerator. Imaginary part from numerator will just be minus 2 sine minus pi by 2. Yeah, and denominator is just, and this is just 5 minus 4 times 0. Yes, now this is 2 times 1 by 5. This is just 2 by 5. Okay, so I think this is the answer. So what we have done is just use this as imaginary part of the e to the power theta, and then find the infinite sum using GP formula. From the answer again find imaginary part, and that gives us the answer. So this is actually a beautiful solution, because you would never expect like the trigonometric functions and the exponential functions would add up nicely to a simple fraction. You would never expect that, but the solution shows us why that happens, and that's the beauty of using complex numbers in many cases. Hope you really enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.